Unfortunately, these don't happen in single discovery aha meetings, right?
Oh.
It's one of these things that, over probably over a year of just constant conversation and understanding what it was we were really doing, that we realized what we really had. And then it became a matter of choice. And I mean, I can tell you when we brought in our Series A, our first financing, our first equity-based financing, at that time we still did not realize the markets we had access to or the potential of the core technology. At that point, I mean, John Doerr will say this, I think, openly. I mean, he was making a bet. He basically loved the team. He thought it was interesting technology, and he thought, with this team and that technology, there's got to be a market somewhere. So, and he loved the cause. I think the cause was one of the initial hooks. He couldn't resist the cause, and it was a great team with an interesting technology.
Yeah. So maybe let's shift and talk about the hydrocarbons for a minute. So you've said that a diesel, a synthetic diesel, really, it's not a substitute. It works in the same way that regular diesel does. Can you talk a little bit about how you picked that of all the things you could make with the hydrocarbons that were spun off of the artemisinin?
Yeah, when I joined the company, we started to think about our product selection from the market in. Instead of thinking about what can the technology make, we started with what does the world need, and we started with really understanding diesel today and biodiesel today. And we realized that biodiesel today had some limitations, and that there wasn't a real scalable, renewable diesel available. So it was from that perspective, kind of market in, that we realized there were three attributes that would be critical for a renewable product to win. The first is it had to have either as much or more energy content than the existing product. Because if you took energy away, it would be a compromise for the whole chain, especially the end consumer. The second thing is the cetane level, which for diesel is kind of the equivalent of octane. It had to have, as much or more cetane than petroleum-based diesel. And the third was temperature. We realized that one of the weaknesses with the oil-based, seed oil-based biodiesels is that they got really sticky and gummy and thick, anywhere below 10 to 12 degrees Fahrenheit. So we decided to focus on a molecule that would have a freeze point of about 40 degrees Celsius below zero. So that's kind of what we did. We said, what are the most important attributes in the market from the customer's perspective? And then once we chose the attributes we wanted to be very distinctive in, then we asked ourselves, could we make that molecule? Well, we actually had an interim step, which was from a chemistry perspective. We asked ourselves which molecules in the world have similar attributes. Then we got to the third step, which was, okay, so there's a set of molecules that could work. And we got to the third step then of saying, so can we actually make those? Can we get the bugs with a pathway we control to make that molecule? And that whole process, beginning to end, once we knew what the right attributes were to focus on, was about a 6-week process. And we think that's pretty distinctive, going from targeting what we want from an attribute perspective to making it in the lab, getting the bugs to produce it in 6 weeks. We think it's pretty cool.